right, good evening, and welcome to Kopernik Observatory. My name is Drew Desker. I'm the director here. I'd like to welcome those of you here at Kopernik, and also welcome those that are watching on the live stream. And we'll just do a little quick pan. So everybody here at Kopernik, wave hi to those on the live stream. All right, it's great to have you here, and it's nice to see some familiar faces, but also some new faces. Who's here for the first time? All right, excellent. Well, I'm glad to have you join us. And as usually is the case, it's as soon as the public shows up, it seems that things start to cloud up. But we did get a chance to see the moon earlier, and hopefully the skies will stay clear enough for us to be able to do some additional viewing tonight. Hopefully Jupiter should still stay above the horizon for us before for a while, so we'll get a chance to take a good look at that. And anyway, we're glad to have you here today. We're coming to the end of our Friday night program season for 2022. We've got this program tonight on the Titans to the Stars. Next Friday we'll do actually an encore of our movie called The Star of Bethlehem, and it's talking about what actually turns out he was an attorney who was also interested in what the wise men saw in the sky back around the birth of Jesus, and using some software but similar to what we use actually here. He came up with some very interesting conclusions, and so that'll be next Friday. And then next Saturday, we are going to host our first Holiday Horizons. And it's going to be sort of a family event to come up between 5 and 9 p.m. on Saturday, the 18th of December. We'll have a bunch of demonstrations and activities for kids, and just sort of celebrate the holiday up here at Kopernik. And again, hopefully the skies will be clear. And we did something similar for this. We did sort of the haunted, what did we call it? The Hocus Pocus. It was the haunted observatory, and we had over 100 kids up here for that event. So anyway, these Friday night programs I really enjoy doing because it's an opportunity for us to maybe learn something new. And here at Kopernik, we're all about sort of lifelong learning and expanding our knowledge base. And so we're bringing in subject matter experts to sort of open our eyes to new things. Not everything we do is astronomy based, although tonight's program is about the space program and where it's been and where it's headed. So we're very fortunate to have Phil Cooper, who has done a number of programs here that have been all very well received. And as you'll see later, if you don't know Phil already, Phil is a world-class model builder, and he brought a few of his models up here today, which I'm sure he'll be speaking to. So we're just going to turn the webcam here so that everybody on the live stream can see you, Phil. Say hi, Phil.
Hello, everybody.
Okay. All right, so we're going to turn this over to Phil, and he's going to take us to the Titans of the Stars.
Okay, thank you. My name is Phil Cooper. I'm from Oneonta, New York, and for more years than I would like to count, I've been extremely interested in space flight for at least 50 years, and have followed the space program in a lot of respects from its infancy. And I've really enjoyed it. I've also been able to experience it, to go down and see launches and talk and meet with the people who actually have made these rockets, or are making these rockets, at least one of them, and also flown in them. So we're going to talk about 3 of them today, and I'm calling them the Titans because they're a class of rocket that these 2 here, the center one, the Space Launch System, and the just one moment, everybody. It's not a talk unless there's a little technical glitch in the beginning. There we go. All the way to the right is the Saturn V. That's really what I would call the GOAT, the greatest of all time, and it's the standard by which the other 2 new rockets will be rated by. And these 2 new rockets, again, in the middle, it's got the Space Launch System NASA's building, and the one here all the way to the right is Starship, and it's built by SpaceX. The Saturn V has already flown, as I'm sure you already know, and the Space Launch System, I wish they'd come up with a catchier name for it, but I'm going to call it SLS from now on, its acronym. That's going to be flying hopefully in February. They haven't really picked a date in it. I'm going to be there in February for a week, so we can guarantee that it won't be that week. But at least they're putting February on the schedule. And Starship is run by a fellow named Elon Musk, and as soon as the fine folks in Texas will give him the permits, he'll start launching these out into the Gulf of Mexico to get as much practice as he can. And what we'll learn will be interesting about this rocket is you're going to think I'm making it up in its science fiction, what they're actually planning to do with these. It's amazing what they've got planned for us and for space travel. Thank you. I want to talk a little bit about what these rockets need to do to leave the Earth, and a little bit about rocketry. So we have some terms that we understand what they are when we talk about and compare these rockets. So to leave the Earth, it takes a lot of speed. It takes a lot of power. It takes a lot of what they call thrust. It's an explosion at the bottom of the rocket that propels it upward. But it doesn't need to propel it straight up, because if you were to actually go in a rocket straight up, gravity is strong enough to pull you down. What has to happen with a rocket is after it gets up out of the thickest part of the atmosphere. Now, how many of you have been into Florida or the Gulf Coast in July? How many of you have been a muggy, horribly muggy day around here? I think we get 2 or 3 a year. That thick atmosphere is what you have to get past. And then once the rocket does that, it has a gravity turn, they call it, which means rather than go straight up, it turns because it needs to go sideways. So to beat gravity, rather than go straight up, you have to turn and go sideways, and you have to go very, very fast. So to get into low Earth orbit, the right-hand corner, you have to go 17,450 miles per hour. Now, low Earth orbit is considered under 1,200 miles. And low Earth orbit really could be 2 miles if you wanted it to be, but the atmosphere is so thick, you couldn't maintain that 17,500 miles per hour. Well, I'm sorry, I rounded it, it's 450. That keeps you in low Earth orbit. Our space station is there, many satellites, a lot of junk, and we were able to attain those speeds and get into orbit 50, 60 years ago. Now, to leave the Earth, you need to still make that gravity turn, get up to 17,000 miles per hour, but you need to boost that to escape velocity, which is 25,000 miles per hour. We're going to call escape velocity now translunar injection, which is a fancy term for leaving here and going to the moon. Because that's how we're going to compare these, because right now they're moon rockets, except Starship considers itself a Mars, Jupiter, anywhere you want to go rocket. And we'll talk about that later. So leaving Earth is all about speed, and it's all about getting into this orbit, going sideways. And that's the way you beat gravity. The Titans, as I'm calling them, are really super heavy launch vehicles. And to get a perspective of what they are, we need to talk about what heavy launch vehicles were and are. It's something that'll lift 40,000 to 110,000 pounds up into low Earth orbit. That's that 17,450 mile zone. We've had 2 of them. They are the Saturn 1B and the Space Shuttle. They're no longer in existence. I was lucky enough to see a Saturn 1B. That's the only part of the Saturn program I could see, and it was pretty amazing. We also have the Ariane 5 that's going to be launching the James Webb Telescope shortly. And then we have China, Russia, and the United States with a couple entries there, the Delta IV and the Falcon. So those are heavy launch vehicles. These that we're talking about tonight are super heavy launch vehicles. That's because they're 110,000 pounds and over. Now, two have existed before. One we're going to talk about tonight, the Saturn V, and the other is a Soviet Union one, Energia, which lasted a year. It was going to launch their space shuttle, but the Soviet Union happened to collapse, and it went into mothballs. And then China's working on one, SpaceX, one we're going to talk about tonight also, and Space Launch System. So we will have two on our space program, super heavy launch vehicles, coming up here shortly. So I want to talk a little bit about how rockets work, because that's similar to all of them. You need to have a fuel on the left-hand side. You can see the orange tank. You have to have an oxidizer, which is the blue in the middle. So it's very much like an acetylene torch that you may have seen before. That's a gas and an oxygen that come together, or two chemicals. Without the extra oxygen, and it's liquid oxygen, you can't get enough of the fire, enough of the explosion. Next, you need pumps, because it needs to grab these liquids and move them at incredible speeds, put them in a combustion chamber, which is next, and then put it through a tiny little hole at the end called the throat. So what you get out of the rocket is not only do you get an explosion and fire, you get pressure, because you're taking all these chemicals and pushing them out the back really quickly. And I wanted to talk about this and the idea of thrust, because that's how we're going to compare these rockets, is how much thrust they have. Because Newton's second law is what? Anybody? For every action, there's an equal and opposite reaction. So that's why you need to thrust. You need to push on the Earth, and that pushes you out into outer space. This is how all of these rockets will work, except the Space Launch System, because that has another type of engine. They have a solid rocket engine. These solid rocket engines are used at the Rocket Fest here at Kopernik. They're a little bit different one, and they're definitely a little smaller. The way a solid rocket engine works is there really aren't a lot of moving parts to it. There's a powdered aluminum and a powdered ammonia that they mix with a rubber kind of compound. They pack it in a long tube. I know this is very scientific. They do think more about it. And in the middle, they put a chamber. It's like an elongated triangle, and it's an open space. And what they do with that is at the front, they actually fire off another solid rocket motor, burn the flame all the way down that combustion chamber, and that sets the whole thing on fire. There's no on, off. There's no let's turn it back a little bit. The minute that they fire that mixture at the top, it explodes and they're off to the races. If you notice that, if you watched any of the earlier space flights before the space shuttle, they kind of took their time going up the gantry a little bit. The Saturn V takes 12 seconds before it clears the gantry. With the solid rocket motors on the space shuttle, it's gone in seconds. I mean, on some of the first launches, the spectators were actually a little disappointed because it was gone so quickly. But it's that instant, quick power. And we're going to talk about solid rocket motors more with the SLS. And it's the same thing through the tiny little hole at the bottom. And then the exhaust comes out, and that produces the thrust. We're also going to talk about two exploration programs in relation to these rockets. The Apollo program was the Saturn V. That was the rocket of the Apollo program. And then you have the lunar and command modules there. That's what they actually took and landed and flew to the moon in. Now, the Artemis program that you're probably hearing about a lot is our return to the moon. And that is the Space Launch System, the middle rocket. It's also something called the Gateway. And it's also something here, which is the Starship. It's a combination of three things. And as we'll learn as we go, our space program now is a bit of a moving target mishmash of some wonderful things and some head-shaking things. And it all comes back to these rockets and why they were made and what they're going to be able to do with them. So we're going to talk first about the Saturn rocket for the Apollo program. It was actually a family of rockets. And whenever you design a rocket, if you have a goal, that hopefully you do, you need to know those three questions in the upper left-hand corner. Earth orbit rendezvous, which is a way of saying, do you want to build it in Earth orbit, keep sending using some of these smaller Apollo rockets that you see here, build it in Earth and then fly it somewhere? Or lunar orbit rendezvous, do you want to build it in lunar orbit and be able to then land on the moon or go wherever you want to go? And then there's something called direct ascent. Now, direct ascent is the rocket takes off from Earth. It flies wherever it wants to go. There's no stages. There's no nothing. It lands, flies back off, then comes back to Earth. The physics of it are possible. The economics and the size of the rocket are astronomical, so it was never done. There was a design for 3 times the size of the Saturn V to do it that way, and those folks really didn't get their way in NASA to be able to do that, and also the price of it. So we did decide with the Saturn V to build the Saturn V. That's there second from the right. And next to it is the cargo version, which brought Skylab up into space. And to the left, the third one from the left is also the Saturn 1B. That's the one we talked about earlier, was a heavy launch vehicle. That's the one I was able to see launch for the Apollo Soyuz mission, where we met the Russians in space. We used to do those kind of things. So anyway, we're going to kind of go back to those 3 questions as we see what these rockets want to do, whether they want to do lunar or Earth or direct ascent, which probably Starship will try. Saturn V had a goal, and the goal was set by President Kennedy, and it's a goal that to this day is studied. If you look in business, when they have classes or seminars on goal setting, they always swing back around to this because it's so simple, it's so clear. It's 2 sentences, and it set a nation on a course to go to the moon, and that we should commit ourselves to go to the moon, return somebody safely, and do it in a decade. It kind of had all 3 things. And as you'll see as we go on through the presentation, that clarity of goal, we don't have it as much these days. But those were different times. We were also in a race to be there first. Saturn V is the brainchild of Wernher von Braun, who was one of the German rocket scientists that came to this country. And this is strictly his and his team's design. Now, President Kennedy's goal in May of 1961, exactly 5 years to the day of him saying that, the first Saturn V took off. So in 5 years, actually 6 years, because it was in development a year, they got this done, which is amazing by any standards. It was nicknamed the Mighty Saturn V. I can show no place where it was first used other than after the first launch, which was Apollo 4. The news media literally got blown over. Their shacks and their chairs and even the windows. If you ever catches a video of Walter Cronkite, he's holding onto the front window because it's vibrating so much it'll break from the sound and the noise from the Saturn V. It became known as the Mighty Saturn V as a nickname after that. It's 363 feet tall, 33 feet wide. 33 feet is about from in front of these chairs here, in front of these rockets, to the door of this room, circular. So it's pretty wide, pretty big. Weighed 6.5 million pounds, fueled. It was never late, it never failed. And one of the beauties of the political climate at the time is they went and ordered 18 of them. They're kind of, well, we'll take 18, and then, halfway through we'll let you know if we want another 20 or so. So that allowed these to be built all kind of at the same time. So it was a great way to do it that we haven't quite repeated yet. Some parts of the Saturn V. And I'd like to review this because it's really, again, this is what all rockets have to do. The first stage of this particular rocket had 7.6 million pounds of thrust, which is incredible from 5 engines is all. They were called F1 because there was G2s and just alphabet. There was just 5 of them. I say just 5. It's just 5 engines lifted 6.5 million pounds. It's just unheard of, and any of the engines we have today just don't do that anymore. It used RP1 fuel, which is really refined kerosene, and it only burned for 2 minutes and 42 seconds. And it only went up to 42 miles. I say only, I mean, that's kind of probably a lot for 6.5 million pounds. But it only took it to 6,164 miles. Now we know they got to get up to at least 17.5 to get in orbit, right? And 25,000. So it does its job. It gets up out of that thick atmosphere. Again, just back to these F1 engines, it's almost a story unto itself. They were not finished in time, really, for the first launch. They had to postpone it. And there was a thought that they might not even get them done, and they didn't know what they were going to do. But they worked very hard, and again, it's a great story. They got it done. Now the second stage, this brings it up to 67,000 miles, not much more in height. It's got 5 of what they call J2 engines, but these engines run on hydrogen, and it's super chilled. The first stage, nothing was really chilled. The oxygen was, but the kerosene was just regular old kerosene. The goal of the second stage is speed, because we don't go up many in miles, but look at that. We go from 6,000 to 15,000. So we're getting there. We're almost hitting that 17,000. Now the third stage, which is loaded, chock full of all those computers from IBM and Owego, is the brainchild of this entire rocket. They rest up here. And this is unique for American rocketry, is this motor can actually be turned off and turned on again. So it's turned on the first time for a couple minutes, and it does get up to 17,500 miles per hour. It burns a second time, and that's what makes these super heavy rockets unique, is they have something that they're carrying up there, besides the equipment, that can get up to that 25,000 miles per hour and get out of town, wherever they're going. And when they burn this third stage, and that third stage has the lunar module and has the command module and all that in it, again, they're off and running to the moon. This is a video of the Saturn V taking off. They've done a great job of, I think, editing it and doing some really close-ups. One thing I'd like you to look for, which is kind of neat, those pumps that we talked about that need to fuel the rocket, they actually have to have an explosion to get them up to speed to take the fuel and stick it to the engines. So when this first takes off, you're going to see orange and black smoke coming up from the rocket. That's the smoke from getting the pumps going. Then you're going to see that smoke disappear and get sucked down into the rocket. That's because those F1s have lit, and they're putting out that 7+ million pounds of thrust.
10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running.
See how it's tipped? It's not going straight up.
And that cloud around the midsection, is that sort of as it's approaching the speed of sound? Is that transitioning beyond the speed of sound?
The maximum aerodynamic pressure.
Yeah.
That's pretty impressive. And it was kind of splicing of multiple versions of the launch, but those engines, as big and as powerful they were actually, you couldn't perceive it with your eyes so much. They were actually moving all of them except the center engine, ever so slightly to keep it on course. It's what they call gimbling, and the motors gimbal. And you'll see an example of that really great with Starship when it makes a landing, how the gimbal has to work. The motors just rock back and forth. I mean, the computers are running it all, but it happens so fast you can't even see it. And this tip over where they start to go toward orbit, that's all handled by the motors moving. There's no little rockets up in there that move it around. It's strictly done by moving the motors at the bottom. So we need to leave the Saturn V and move on to the SLS, but we need to just go over a little bit of history because the Space Launch System has a little murky lineage at best. First we had the Saturn V, ended in '73, then the Space Shuttle. Now they knew that the Space Shuttle needed to be replaced, so in 2005, George W. Bush, the younger, he set America on the path of the Constellation program, which was Ares 1, which is in the center. That's just a big solid rocket booster from the Space Shuttle. On top of that is a capsule called Orion. And the Orion capsule has local roots here because the Lockheed folks locally, they make the human interface systems inside the capsule, the touch screens. And they actually gave a talk here, which was very interesting. But maybe we can have them back again sometime when they actually start launching these in earnest. And they decided to split it up and have a cargo version, and this other version on the right, 4, was more like an Apollo version. It gave them some flexibility in answering those 3 questions. Do you want to put it together in Earth orbit? Do you want to go there directly, or do you want to put it together around the moon? Unfortunately, it was a good idea, but Congress didn't appropriate enough money for it. So President Obama came in 2009 and he canceled it. So the Ares program was no more, and really it was having a lot of difficulties. There were cost overruns because contractors aren't penalized for overrunning. They're just given more money. It's a weird, wacky system. And it just wasn't going anywhere. And they wanted it, they thought that since they were using shuttle parts, they could get it done in a few years. It just didn't happen. So anyway, they canceled it. And President Obama, in 2011, he starts us on the path of the Space Launch System. So the Space Launch System is actually using the technology of the Space Shuttle and the Ares program which they canceled. Which, when you think about it, it's going to be our next step in space. We've left the Saturn V, which is a phenomenal machine, no problems, and they're ordering 18 at a time, so they're set up for some mass production. So we go the route of kind of putting this mishmash together. And they're finished with it, and we'll talk about the goods and the bads of what it can and can't do. But that's its lineage. So it's really, if you look at it, it's smaller than the Saturn V, it's bigger than the Space Shuttle. It's kind of a combination of Ares, and it needs a mission. So the goal of the Space Launch System has changed over time. I started out with inheriting the Ares one, which was visit an asteroid, which just really did not catch the imagination of the American people. Also happened that Japan and other nations were landing probes right and left on the asteroids and returning samples. Go back to the moon, then first woman on the moon, and then go to Mars. The public relations people keep finding a use for the Space Launch System. But when you look at it from just a perspective of what it is technically, it is a fine machine. They've worked out some of the trouble that the Ares had. It's 322 feet tall, and we'll tie this all together with how tall the Saturn V is. Which you can see here, these three models are to scale. So it's a little bit smaller. It's got a little more thrust. The solid rocket boosters on the side, unlike the space shuttle, they don't want them anymore. They're gone. They fall in the ocean, and that's it. That was a great idea with the space shuttle, but it kind of ended up being more expensive to refurbish them than to just let them go. And it's sad but true. Both the Saturn V and the Space Launch System do not take reusability into account. Only the SpaceX one does, and we'll talk about that in a bit. Low Earth orbit, it can get it 231,000 pounds. And to the translunar orbit, it can get 59,000 pounds. Now, if we go back and look at what the Saturn V was, the Saturn V could put 310,000 pounds into low Earth orbit and sent 231 to the moon, not just 59. So the capabilities of the Space Launch System are less than the Saturn V. So when they say that they're building the most powerful rocket ever built, they're talking about the fact that it has 8.8 million pounds of thrust as opposed to the Saturn V. But if you want to look at it as to how much it could put in space, it's not kind of beating the Saturn V. But they have plans to expand it. And we'll get into that in a little bit. This is breaking down what the rocket entails. There's a core stage with 4 engines that used to be on space shuttles. And when I say used to be on space shuttles, they literally used to be on space shuttles. They are refurbished engines that have flown in space before. It's mated with solid rocket boosters, which are the same ones as the space shuttle, except they've added a 5th segment in the middle. So they've kept the top, they've kept the bottom, put a 5th one in the middle. They're going to get 3.6 million pounds of thrust out of each one. So when you run the math on that, those solid rocket boosters get it into space 75 to 80% of the way. And the rest of this core stage with the 4 former Saturn or 4 space shuttle engines just push it that last little bit. But again, in a way, by design, we're putting all this technology together that was designed to go in low Earth orbit. And we're asking it to go to the moon. So there's some things that we need to do with it. One of the reasons it can't go to the moon right away, when I say go to the moon, I bring something with it. It can send a space capsule to it, which we'll get into what version will do that. But right in the middle top, it's called the interim cryogenic propulsion stage. That's a mouthful. Rather than build a second stage, which they need in order to save money, that's the second stage from a Delta IV rocket, which we talked about in the beginning, one of the heavy boosters. So to save money, they limited what it could carry into space. So I mean, I guess one way to look at it is they're getting it done, they're getting it built, but then it does limit what you're gonna do for it. This is the Orion spacecraft, which was finished and built for the Ares program. Again, parts of it built locally. It's much bigger than the command module. That's the Apollo one on the right-hand side. Its capabilities are 2 weeks undocked and 6 months docked. So, I'm sorry, 21 days undocked. The Apollo could do maybe 3 weeks if it had to. So it does have some more capability, but by itself, it can only zip around out there for a couple weeks. But from all indications, they have already flown it, that it is a very reliable craft. The second part of it, where the solar panels are coming out, is made by Airbus. We only make the capsule. So here's a little bit explaining how they're going to make the Space Launch System kind of bulk up. At the bottom, it talks about blocks. Blocks in aviation are groups of aircraft that they build at the same time. So our space industry has adopted the same thing. So it's like us calling it a version. So the first version, or block, is what's going to launch in February. And it's just going to send the Orion capsule out around the moon for, I think, a month or so, and then bring it back for a landing on Earth, a splashdown. So that is all the Block 1 can do. And they're going to do that 3 times. Now, they haven't gone out and bought 18 of these. They bought 2 and said, we're going to want a third. So they're sort of started making the third. But what we'll find out is the Space Launch System is so expensive. $2 billion a launch, when the Saturn V is only $1 billion with today's dollars. And depending on what accounting you use for government accounting, it's going to be closer to $3 billion. So they don't have money to launch it once a year. So that's going to be challenging to run any kind of space program. So anyway, what it needs is something called the Exploration Upper Stage, and we'll go into that a little bit later. But that will allow, again, that's 3 years from now. And then there's 5 launches with this 1B block, which is going to have the upper exploration stage, a really beefy second stage. That's if they get the money. That's in doubt. And then they wind up here at the end with this block 2, and that's where they want to be. And that's all remaining launches. So that's 8 years from now, really, before there's a rocket that can, with confidence, have the weight to bring equipment to the moon. So Space Launch System will be part of our moon effort, but it's not really going to be like the Saturn V. It's not going to bring launch vehicles. It's not going to do a lot of stuff till later on. And this is what's holding them back. They went for the cryogenic propulsion stage rather than the one on the right. I mean, the differences are astronomical with the amount of thrust and whatnot that it can do. But it was either that or have nothing, I guess. So the politics behind the space program is there's more to the politics really than the technology. If you had the money and got rid of the politics, I have no doubt that we'd be on Mars by now. But it's complicated. And you can see, again, you can see in the shadowed out versions of what the Space Launch System looks like, how big it is and the difference it is. Since it hasn't launched yet, we'll have to watch an animated view of how the Space Launch System will launch. And it will be exciting. This February when it launches, it'll be unpersoned, but the next flight will have probably 4 astronauts in it. And for the first time in a long time, they'll be circling the moon. And that I'm sure will get some good buzz for the Space Launch System to be able to get some juice behind it. In Congress right now, it's described not as a rocket or a space system, it's described as a job producer. You know why parts of the Space Launch System, or even the Apollo, is produced in all 50 states? That's 50 votes in the Senate, plus more. So they spread it out, and that's not quite the best way to make something that spread out, but it does get the votes. Now we're on the Starship. This is sci-fi right here. This is going to be pretty cool. They're doing things that are so far out of the box that they look unbelievable. Starship's goal is Mars, 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 and then after that, Jupiter, Saturn, and wherever you want to go. It just so happens that our government is paying to have some development to help us go to the moon, so they're just kind of make a stop at the moon of their Mars rocket. So it's a company has a man named Elon Musk who's in charge of it. It's a private company. A lot of what I'm going to present to you is from social media. It's from some NASA releases. They don't have to release anything about it, so it's bits and drabs. And there are literally people staked out at their launch site with long-range cameras, and every time they make a change, they put it on the internet, so you can kind of keep track of what's going on down there. But to the left is what SpaceX Starship is going to be. It's got a first stage on the right-hand side called the Heavy Launch Booster, and on the left it's called Starship. All the terminology is confusing because the whole thing is called Starship now. So I'm going to refer to it as Starship First Stage and Second Stage, because they have two different named things, but together they're the same, one name, but what's in a name? So on the right here, that's not a rendering. That is the first and second stage of Starship at their Boca Chica launch site off the coast of Gulf of Mexico. They're working to get a launch going here pretty soon. Rather than run on hydrogen like the other rockets, it's going to run on methane. Now, methane for a couple of reasons. One, methane is cheap, and that's big for financial reasons because this is a business, privately owned. It's very explosive, just like hydrogen and the others, but it's the stability that's really great. Hydrogen, if we all remember the Hindenburg, I mean, that could easily happen to a rocket. And they built it out of stainless steel, which had everybody's heads kind of scratching. All the other rockets are out of aluminum, and there's carbon fiber. And they started out with carbon fiber, but they found that it works great because it's not very, it's less in weight. But when it gets cold, it gets brittle. And their vision, which really people didn't know at the time, is they want to launch these rockets 3-4 times a day. They're talking about this on the right here, this Starship, stage 1 and 2. Stage 1 comes back down on the ground, they load another 2 on it, and up it goes. With the turnaround time of an airline. So I told you it's going to be like science fiction, didn't it? But they're on target for that. I mean, how many here have seen one of the Falcon 9 boosters land that they have with the... Yeah, 5 years ago, if you were sitting at NASA and you said, this guy Musk, he's going to have a booster land on a ship out of the Atlantic Ocean. This guy's crazy. Well, I mean, crazy enough to do it. So this is what he has planned. He's got a Raptor engine, which he's going to mass produce. They're going to make 3 a day, 1,000 a year. Now they're smaller engines, which is why I'll just skip to the bottom. He needs anywhere between 33 and 39 of them on the bottom to get his thrust. But he's planning on developing 16 million pounds. 7.5 was the Saturn V, 8.8 was Space Launch System. So if we look at thrust, he's the winner. or Starship is the winner. But as we'll see, there's some price to pay for that. Starship will have 9 engines in it. They've got the engines tucked in down here. Because as we'll see, the way it's going to land, the engines have to be tucked up in here because it's the wildest ride in the wilderness. And here is the 39 plus motors here tucked in. And if you notice something, these are fins, and there are no landing legs on this. Yet it's going to come up and down 3 times a day. So we'll see in a little bit how they plan to land this, actually both of them. This is the Starship Stage 2, and this is live. It's not a rendition. This is after it went up about 3,300 miles, and then it flopped over on its belly. And what it's going to do is just these fins, which are movable many times a second, are going to keep this perfectly level. It's what's called the belly flop. The last 400 or 500 feet, it's going to flip like this. The engine's going to fire and it's going to land. I think that the astronauts of the future who ride that SpaceX Starship are going to have to really have some nerve to be able to land like this. So this is a practice run. It's the first one that they did that didn't explode, and we'll take a look at it. And just watch how you can almost see the fins move a little bit, but look how dead solid it comes down.
T plus 4 minutes and 40 seconds. Starship has transitioned. It's flipped to the horizontal mode, beginning the descent back to the landing zone.
So those fins are keeping it alive. Those are just gases venting. They're not rocket motors or little reactionary motors that are trying to keep it anything. It's strictly those 4 fins. They're braking it and they're adjusting it a little bit. The computer modeled the heck out of this and came up with the exact angle of attack to land, which I promise is coming up shortly. At the point that it flips over, no. Maybe a little, but it's, as you'll see here, when it does flip.
Coming up on 5 minutes, 45 seconds. We're down below 2 kilometers. We're preparing to light 3 Raptor engines to begin the flip sequence. It'll culminate with landing on the landing pad in Boca Chica.
Watch how the motors gimbal, how they move, how much they move. Just some tiny little landing legs, about the size of a paper plate with a rod that goes up in, it pops out. About a dozen of them, and that's it. There it is. They weren't happy with that fire. That's leaking methane, but unlike the earlier version that made it blow up, this one doesn't actually blow up. So to keep it from burning up when it just dives down and does the belly flop, this is shuttle technology as well. As you can see, this side is all stainless steel. And this is all black heat tiles, which is a custom blend made in Texas by SpaceX. And here they're gluing them onto Starship Stage 2. If you look all the way to the right, there's a foam pad that kind of hooks into these little hooks, and then they put some glue on it. It's a hexagon because if they get a leak of heat through there, it's short sides. There's no long run. So the most you can have is a burn through for just the width of one of those sides. And that's another reason why they went with the stainless steel, because that could take, not that it could take losing a whole bunch of them, but that can take a little heat, stainless steel. On the left, they're putting on the tiles, which I usually do not comment on social media because I rarely like the storm that comes from it. But I did have to put in comments on the SpaceX site. Does this strike anyone as odd that the space shuttle tiles had to be put on in a hermetically sealed area with technicians in white lab coats? And this is just a person in a hard hat, and he's got like glue caulk gun, and he's putting these on. You know, I can't tell you the response that I got, telling me that I didn't know what I was talking about. Anyway, but they did run a static fire test, which is when they turned the engine on, and a whole bunch of them did fall off, so they do have a issue. Not that I felt vindicated, but don't put anything negative on any of the social media for Starship or Elon Musk. There is a cult following of that company and the people, but it is still a worthwhile company because they're planning some amazing things. But again, this is a ship waiting for nothing but environmental study on the coast of Texas. Elon Musk moved from California to Texas because he felt that it was more of a better climate for business than California. He didn't like the rules and regulations there, but he kind of got stuck right in the middle of one in Texas as well. So sometimes it doesn't matter where you go. People do kind of care about the environment. So anyway, as soon as they get past the environmental studies, he's going to launch. This is a quick insight of Starship. Nobody knows what they're going to put in it other than the volume of it is like a 2.5-story building. So they can launch cargo. They want to get approximately 100 people, although they're in tiny, tiny little chairs. But they only have to, but I guess I'd sit there if I got to go around the moon. So, because that's one of the things he wants to do is take 100 people around the moon. Just as a sidebar, a Japanese billionaire gave him $2-3 billion. He's technically the first to use Starship to go around the moon. And he's picked like 50 people, 20 people, I don't know what it is. So again, you can't make this stuff up about SpaceX. So there's all the motors at the bottom. It changes. That's why I gave you a range of 33 to 39, because it will change by tomorrow. Just a couple of renders of it on the pad and launching. This is where it gets good. Still with the high thrust, when they put the stage 1 of the Starship in orbit, it has no fuel. So over a period, it's used it all up to get to orbit. So for a period of a month, they're going to send up additional Starships. They're going to cozy up bottom to bottom, and they're going to refuel each other over a period, refuel the one over a period of a month before it can head out to the moon. I know it's so crazy, isn't it? But that's what they had to give up to be able to do what they're doing. The idea of reusability has a cost. So for them to have all that thrust, they need it because they need the extra fuel because they got to land. So there's always a price to be paid for it. But as you'll see, the costs are going to be pretty dramatic when we get to the conclusion. So this first stage with all 39 engines has no landing legs. So it can't do a belly flop. So this is how it's going to land. And the device you see called the Mechazilla and the chopsticks is already built and waiting for launch. Now, wouldn't you think I made that up if I just came here and said, how's that going to do that? The cost of landing gear on Starship was 15% of the weight. So they would have needed 15% of everything. So these little directional fins come out to help it while it is coming down through the atmosphere. just like it does on the Falcon 9. But because this is such a larger craft, these are really, really heavy, so that when this comes down, it can set on here. That's the hope. I hate to be an optimistic pessimist, but I hope they're building a couple of these, because the first couple times they try it, it might be. But you got to admit, when you watch their landings on TV, especially, okay, they hit a ship in the ocean. I mean, what they have with their computers and their navigation is, it's just world-class coding going on there. So that's, and it gets even better too. On the left is a oil rig that they've purchased and are refitting. They purchased 2 of them. They're called Phobos and Deimos, and they're going to build the launch towers and all the facilities on those and launch them off the ocean. Because the sound that comes from these rockets is incredible. And down in Florida, they'll put up with it once every 4 or 5 months, like the Saturn V was, because there's nothing more noisier than the Saturn V. Is 204 decibels. A rock concert is 110. The chainsaw is 110. So it's double that. It looks like Starship's going to come in at 180, which again Florida would put up with, I think, but not 3 a day, every day. So part of it, they're going to go off the ocean and do it. And hey, why not? I think if they can catch with Mechazilla and the chopsticks anywhere, they can do it on the ocean. And this is the gateway on the right. This is something that they're building as part of Artemis. And don't really want to get into the program. We had a great program on it here because a fellow that's working on it, he was from Johnson City. It's very interesting. It's a little small space station that's going to be above the moon. And that's where the astronauts are going to stay after they go up and down to the moon. But, and the next slide will show it even better, but to the right is, we've awarded Starship the contract to go to the moon. So this is what Starship on the right is going to send to the moon. And you can see the little Orion capsule down to the right, and then there's a gateway. I can't help but think that somebody isn't going to say, well, we're kind of all set with one of the Starships there. Look how big that is. But they're still going ahead with Gateway. That's going to be launched by commercial rockets because the Space Launch System is not beefy enough to do it. And there's the Orion capsule. So I have no idea what the future is going to be. I do know that the Human Landing System was awarded to SpaceX. And on the left, you'll see I imposed, that's what the lunar module looked like from the Apollo program. And this is what they're going to land on the moon. Right above the American flag is a door, and there's an elevator that takes them down to the bottom. Okay, if any of you have seen, I think it's Conquer Space from 1957, that's how they got on the moon. And this is the reality. This stuff is built. Now, he won this contract from the national team, which is Blue Origin, Jeff Bezos, an Amazon company, Lockheed, Northrop, and Draper. Draper's, they make AI technology. But this is Lockheed and Northrop, lost to SpaceX. There's another company in there called Dynetics. They look like they do hyper missiles for the government is all I could see. So, but in winning that, when I first heard that, I said, that's almost like saying the Space Launch System isn't going to send anything to the moon. Because all the rovers or whatever you want to send to the moon have to go in this craft, and it's launched by the big stage one, the heavy booster. So I have no idea what other vehicles, although now they're saying that that's the first round. There's going to be a second round of competition for lunar landing equipment. But when it's said that we're going back to the moon in 2024, that's how we're getting there. Which means Mechazilla has to work, which means the chopsticks have to work, which means the Starship first stage needs to be refueled for a month in space. Now, knowing all this, when you read the report of the winner of the Human Landing System, NASA was thrilled. They almost didn't see a problem with it. This is exciting, the great idea, new technology. And I think it is too. But the reality is space is dangerous. And space flight is dangerous. We've lost craft, we've lost people, and whatever the thrust is on the bottom, it's a violent explosion. It's not the Millennium Falcon. Things will go wrong. And I guess things could go wrong with the Space Launch System as well. But, I mean, I'm ecstatic about it. I think it's fantastic. Is it going to happen in 2014? Boy, I don't see how that's going to happen. Or 2024, I'm sorry. Yeah, there's no way it could happen without time travel. So, but it's very exciting. And to watch it, I mean, I know I'm going to be glued at the TV for the first Mechazilla landing. I mean, who isn't? The biggest comparison I can show between the two is on the left is a Space Launch System. It's in the Vehicle Assembly Building. It's wrapped in a cocoon of engineers and platforms. It's climate controlled. There's perfect humidity, plenty of light to work. There's Starship on the right. This is being built by a crew of Texas silo builders, and they're putting these together. And that's fine because, remember, they're not afraid to fail. They just want to get these going and learn. So they're just kind of slapping these together out in the desert. I mean, it doesn't even look like they pick up their stuff at the bottom at the end of the day. But this is where this is where the first launch is going to come. It's on the Gulf of Mexico coast, so they're going to shoot over toward Florida that way. Just a final comparison. Height, which doesn't matter. They're all close. Thrust, yes, Saturn V has the lowest, and Starship the highest. But as you can see that we talked about with having to be a month in orbit to get refilled, it's not a perfect system. But what's important to me is the low Earth orbit. The Saturn V put 310,000 pounds in orbit. Starship, nor Space Launch System, will not achieve that. Space Launch System, no matter what version. So translunar injection, which is our 25,000 miles an hour to leave Earth. Again, 107,000 pounds of the Saturn V. SLS a little light at 59, but when they get that second stage we were talking about, they're going to get up close to that, but less. And Starship is only publishing 220,000, no matter where it's going, to the moon, Mars, wherever. That's all they're publishing. That's what it's going to have in it. And the cost, Saturn V is $1 billion a launch. You know, it sounds like a lot of money, but boy, it did everything. It went to the moon, it came back, it launched Skylab. It was very elegant in how it did all that. It was expendable, there's no doubt, but it was only $1 billion, which I think these days we can say that, can we? It's only $1 billion with what everything is costing and we're spending. SLS, maybe under $2 billion, some say $3 billion. There's funny accounting going in all these programs, but expensive. Starship's claiming under 10 million. No one's believing that. They think it's going to be closer to 110. They're not counting the month-long amount of fueling trips to fuel it up and a lot of other expenses. But let's say we even take the $110 million. That's why NASA signed them up. I mean, they didn't have anything with the Space Launch System that they could use anyway to send stuff to the moon yet. So they're giving SpaceX a shot at it. So, and it's not to devalue the Space Launch System. I think in its final form, 8 years from now, if it can keep the budget with that second stage, you know, it's the tortoise. The hare, you know, hares sometimes are faster and make it, and hares sometimes don't. I look at Space Launch System as a hedge. We'll see what happens. I mean, I root for their success. I always like to close with a couple of quotes. My favorite person, 4 quotes, is Carl Sagan. He talks about us being ready to set sail for the stars. And I do like the one on the bottom a lot by Neil deGrasse Tyson. You've got to send humans. I mean, and I think that's true. And I'm a big fan and advocate of our space probes and all. I mean, the Perseverance rover and Curiosity, I mean, Perseverance is just amazing. But it won't have the effect of 4 people orbiting the moon, looking down at that and saying, you know, that's amazing. So maybe we can get some some fire in the program. Questions?
All right. Well, we do have one question, at least from our live stream, and so that those here formulate your questions as well, and also give some time for some additional live stream questions. So Maureen asks, if Phil were to set a goal for the space launch system, what would it be?
If I were to set a goal for it, I would say that it needs to mimic what the Saturn V did. That I think we need a launcher that can do it all. It can take the equipment, it's kind of self-contained, and have that other version, which Apollo never got to, was the cargo one. Because that's kind of the biggie. It's just who can throw the most stuff up. And the Saturn V, ideally my goal would be to build a Saturn V again, but we can't do that. So it is to mimic that launch ability as much as the Space Launch System can. Because we don't need it to send space capsules or space probes anywhere. We've got that with the heavy launch vehicles.
All right. Any questions here up at Kopernik?
Yes.
You do, let me come out here with the microphone so that our people on live stream can hear you as well.
Do you have any comments on the rocket that's going to send up the James Webb Telescope?
Yeah, it's very reliable. And it scares me because the James Webb has been so delayed and it couldn't have any worse luck. They dropped it at the launch pad. I guess it wasn't really a drop. That's, I guess, maybe more media-like a slip that in stopping it from slipping might as well have dropped it. But the Ariane 5 is very reliable. I mean, I looked through many pages and I didn't find really any failures in a very, very long time. But it makes me nervous because all our eggs in one basket. But they decided to go with them instead of one of our launchers. Again, I think it's because of our launchers were really booked up more than the Ariane, but it scares me. I know the people who built it are scared.
Yeah, actually, a couple of weeks ago we had a talk about the James Webb telescope, and besides the launch, all of the systems that have to happen to actually sort of assemble itself out in space, because it's sort of all origami together, and then there's these 5 layers of I guess Keptan or some material to keep heat away from the sensors themselves. And if you get a chance, go back and look at the James Webb YouTube program, and you'll hear that video. It's they're scared. But we did have another question back here. Hold on.
So my question is, how is how are the Saturn V's better than the more modern rockets? Like, it seems like they could do more than with our newer tech. How does that work?
They had an unlimited budget, and they used the technology. It was new. I mean, they built upon previous rockets, but they had the advantage of you're going to the moon, and they answered one of those 3 questions that you're going to do it with lunar rendezvous. So they had the clarity of goal. They had unlimited money at least halfway through the program, and they just really had a dedicated workforce that they've gone back and they've taken apart the F1 engine, and were amazed that it was handcrafted. And what I mean by that, the welds were all done by hand. They can see where there was they started to drill with a metal drill bit, but it was the wrong spot, so they moved it over and drilled there. They signed them. They were just handicrafted and unique. But again, they knew exactly what they were building it for, not a whole system of rockets. So that's why I feel it holds up. And they could get the blueprints. They did get the blueprints out when they were going to build a space launch system. I don't know why they didn't go further.
Sort of an artisan rocket, I guess, right?
Yeah, but it's not reusable, and that's where things are headed.
But yeah, I've got another question over here. Pardon me a second. I'm gonna slide over here.
I was wondering if there are any steps towards making rocket production more environmental friendly.
Yes, actually, I meant to mention that with SpaceX, methane and the liquid oxygen, when it burns, makes water vapor. So the SpaceX rockets will be environmentally friendly. If the sound doesn't kill the birds and other things in the environment, it's going to be good for the air. But some of the other stuff, they're working on that, but it's hard to do something with 180 decibels that doesn't upset something. So, but yeah, the exhaust is, unlike the Saturn V with kerosene, it's nasty. But they only launch twice a year, so not too bad.
And as I recall, with the current rocket systems, they actually dump a lot of water underneath to actually absorb a lot of the sound.
Yes.
So that helps reduce some of the sound pollution, for lack of a better term.
Yep.
But,
no, it does. It's a little, because they want to preserve the launch pad from the sound, and maybe some of the immediate spectators. But after it gets up to a certain height, then and they run tests. I mean, with a Space Launch System, they made a 1/5 scale version, and they put microphones all over the place, out 10, 15, 20 miles, and they recorded it. And they did the math, and they think they're going to be okay. I mean, everybody's going to want to watch their windows, but I've seen nothing for SpaceX. I think they've decided they're just going to have to launch on an oil rig off the coast. But why not?
all right. No further questions on the live stream. Another question here. Oh, pardon me a second. Just slide by.
I don't know if you know about this, but I've heard about the relationship between NASA and SpaceX in terms of like legal and business relationships. But since we had like the International Space Treaty and everything, has SpaceX had any problems with like politics or having to discuss with other governments what the implications of them going to space is?
Good question, and I can tell you that they'll not answer any of those questions. They're very, very strict. I can tell you that the relationship with NASA is a partnership. A lot of what SpaceX is doing is being done with NASA money. The Falcon 9 development was paid for by NASA, and each trip to the space station in the Falcon 9 is paid for by NASA. So NASA's their biggest customer. So they'll answer as much as they can, but from trying to research what everything, the stats for the Starship, it was very hard to find because they're a privately owned company, and I would count that as a negative if it wasn't for somebody like Elon Musk, who's one of the visionaries of our time. But NASA will be abided by the treaties, so when they launch for NASA, they'll have to do something, but when they're launching on their own, nope.
All right. Any other questions? What we'll do, though, is I'm going to just move our camera over here just so that the people on the live stream can really get a sense of the detail of the models that you've created here. And
if you do come up and look at them, those little things on the bottom are to scale people. So you can get an idea on how big it is.
And Phil has offered to loan us for a short period of time these models, so they will remain here at Kopernik for at least a couple of weeks. And so if you do come up on a future time, these will be here. There will be a big "Do Not Touch" sign on it. But I believe you said the SLS and the Starship are both 3D printed.
Yes. I did want to show this because it's a good idea of scale, and I did forget during the presentation. This is what we sent to the moon on Apollo 11, and this is the size of Starship that's going to go to the moon. So with our other rockets and the Space Launch System and the other systems we have, we'd be able to send maybe something just a little bigger than this. But look at the size difference. So, halfway up is about where the livable space was, so I'll put that there. Look how, it's just, I see why NASA went with them. I just hope that things go well. But anyway, this is the size of what we actually sent to the moon.
And could I ask you to do one more thing? Just show our viewers the bottom of the Starship. and those all those engines with the diesel on it.
Minus the wooden peg in the bottom to stop it from tipping over. But
Right. So there's that as well.
and how they find out there's engine change is a flatbed truck drives up with a little crane, and they either put an engine on or they take an engine off. And somebody gets on social media and says it's now 36. Crazy. But it's their motto. They're just going to get this stuff out there. And they learn by failing.
I think one of the things that, again, you see the size of the Starship in that, the lunar landing system, assuming they use something along those lines. When you look at sort of ideas of what, when we actually finally populate the moon, you talk about all those big habitats and everything that are going to be on the moon. It's going to take something in that size to try to land, something of that volume. And
then we'll come up with something once a year to send up on the Space Launch System.
there you go. So I understand the skies are not great right now, but we'll hang here for a little bit longer. So if you want to come up and take another look at the models, please do. I will tell you that again. We coming up next week, next Friday night is the Star of Bethlehem movie. The Holiday Horizons on Saturday. We are going to possibly do a live stream of the launch of the James Webb. Right now is scheduled for early morning on December 22nd. So we will most likely do a YouTube live stream for that. Also, there's a comet Leonard right now that is in the skies. It's sort of just now starting to go around the sun, and depending on what that looks like, we may, like we've done in the past, like with Comet Neowise, we did a live stream through our scopes, and Jeremy, our live stream astronomer, will most likely be the one handling that. So watch our website for that. In January, we'll have just one program, probably a Winter Skies program, and then finally on February 19th, Kopernik's birthday, actual birthday, will be our Winter Star Party. And we do have cake and everything, and we get to sing, and it's a great time. So we'll look forward to having you come back up for that as well. So thank you all very much for coming, and let's see if we can blow some of those clouds away out there. Thanks again.